And hello everyone, welcome back to this video. So the last video we're actually looking through DWSim code, and we're trying to bring some of the classes over. Okay, and we find out that very messy. However, of course that gives us motivation to write code properly next time, so that anyone who wants to use our code in future is not going to have that much of a nightmare. Okay, so here's the goal of maybe the next few videos. We want to sort of port over unit operations, okay, such as the pipe.vb, pump.vb, heat exchanger.vb, heater.vb, and maybe cooler.vb. Okay, so we'll start maybe with a pipe. Okay, so all of these will be dependent on some other classes, and it will be a monumental task even to port one of these unit operations over. Okay, but that is exactly what we are going for. Maybe at least port over some of these components, make them tidy up the code. Okay, the process is known as refactoring the code, and hopefully make it somewhat usable, okay, to someone who does not have those Microsoft Windows forms or .NET framework. Okay, we'll try to put all this into a usable library which is based on .NET Standard 2.0, so that it can be used both by .NET Framework and .NET Core. Okay, of course, best if we use something that's cross-platform, free and open source. .NET Core is the closest thing we can get from Microsoft for that, if we are stuck with this. So this is the whole reason I was using learning .NET Core in the first place, and hopefully let's start. Okay, so where do we go from here, right? So if we take a look at pump.vb, this is the pump unit operation class file. You see there's a lot of things going on here, such as these properties and lots of other functions right here. Okay, curve power, curve system head, blah blah blah. There's just too much going on right here. And it also includes the thing for creating curves. So there's a lot of things going on here. Okay, so what do we want to do with this code to actually make it neater? Okay, so one of the things with this code is that you can see how many namespaces it imports. It's quite a few namespaces, nothing wrong. Of course, the system Windows forms is not going to be available on Linux, unfortunately, so we might want to take that out of our dependencies and maybe do something, cut out some of the the need for that Windows forms. So we just make it fully command line, fully in C#, that we can call some of these call some of these classes or whatever, right? So what we want to kind of distill down whatever's in this pump class down to its inputs and outputs. Okay, so let's examine this code, and of course we want to know how this class actually interacts with other classes, because it's going to inherit and implement certain interfaces, like this interfaces iCustom XML serialization, which really at this point in time makes no sense to me why it needs to be there, because I don't know how this code works. Okay, right, so that's a kind of no, I won't say that. Okay, that's a lot of things to deal with, but let's go through some of it. So we want to understand how this pump.vb inherits from other classes, interacts and uses other classes such as this thermodynamics, streams and everything. How does it use the namespaces and libraries over here? Can we package this thing into a library that's at least neater? We have some comments as well. Yeah, that's what we want to look for. Okay, so as you can see here, there's a lot going on, and of course since we want to know how this thing actually relates with other classes, where does it inherit its functions from, we might want to use some mind mapping software. Okay, the proper term for this is called dependency mapping. Okay, it's to see how classes interact with one another. Okay, dependency mapping is basically process of finding out which applications are dependent on what in the context of network infrastructure. Okay, we don't want to do it for application, but we want to do it for our class dependency mapping. Okay, let's see whether there exists such a thing on Google. Okay, class dependency diagram. Okay, so this thing is called ndepend. We can see whether this thing is available. Otherwise, the fallback is always to use mind mapping software. Okay, class dependency diagram. Let's see whether anything's here. There are no packages found. Too bad. Okay. Here we. Visual solution. Blah blah blah. Now, class dependency diagram for your code looks like Visual Studio does have this kind of thing going on. You can copy paste. I don't know. Dependency graph may be the thing. Yeah, you see, dependency graph. Okay, so we want something like this. If a class depends on another class, we want to at least map it out. Okay. So I guess the easiest way in terms of downloading software and configuring is just to use mind mapping tools. So the mind mapping tool you can use is Freemind. The other one I like to use, maybe consider using, is Minder. Minder, unfortunately, is Linux only. If you want to use the other one, you can use a Freemind. Freemind is definitely cross-platform. It's written in Java. Okay, so it should be quite okay for you to do this dependency mapping. However, look at these diagrams here. They may not be as nice as Minder. Minder looks a lot more appealing to me. Okay, you can use Freemind if you want, but I rather choose Minder. You can use any other mind mapping software you want. It's not specific. So I'm just going to install Minder. Okay. So from the software store, I'll just apply and it will install Minder very quickly, as you can see here. And let's see whether this works. Okay, I'm going to open terminal. I'm going to open Minder, and we'll have some unnamed document here. So we can just add a root node. Okay, so that's where we can start. Then if you press the tab button, I can say maybe this is a class 1, for example. Okay, let me backspace and delete hello world. Okay, so maybe that's one of the classes you have in there. So how do I structure this? Okay, so let's say we have maybe we can save this as a new document or make a new document. Okay, this thing is called unnamed1.minder. You can save the file as let's say we put in our .NET test or .NET Core YouTube. Okay, or maybe put in a .NET Core.YouTube. Then we'll just make a new folder called dependency mapping. Okay, so we'll just call this unit pipe class dependency mapping. Okay, so what do I like to do here? Okay, I'm not the nice thing about mind maps is that we take out all the codes, what's going on. We just simplify classes down to their inputs and outputs, very much like interfaces. So the whole thing about having this mind mapping software is so that we can have a bird's eye view of what's going on and we reduce things down to their inputs and outputs. So if you want to scroll up and down, you can actually use your mouse pad. Okay, let's look at the shortcuts also. I'm still wanting to look at shortcuts, how do you scroll around. Okay, let's see, search. Is there anything else? Can I scroll around? Okay. Oh, I like this thing here. Yeah, you can change the layouts if you want, apparently. So that's really up to you. Okay, or you can have them manual, you can have them upwards, sideways, to left and right. It's really up to you. So this is a very nice thing. Okay, I'll just use a solarized light. Okay, so at the end of the day, yeah, we can use Minder to sort of map down what a class should do and how it interacts with other classes. Right, so at the end of the day, what is a pump supposed to do? Okay, a pump class supposed to do. Okay, it's supposed to take in some sort of data, like an input stream, an inlet material stream, and then it's supposed to an inlet material stream is supposed to have maybe some sort of mass flow rate, some sort of pressure, temperature data, all of these things, and then temperature, pressure, and flow rate, that kind of thing. And then at the inlet of the pump, it's supposed to have that, and the outlet of the pump is supposed to have temperature, pressure, flow rate as well. So all of these things need to be calculated as a fluid flows through a pump. So at the end of the day, we just want the pump to receive an input and give an output. Okay, so yes, that's the idea. All right, so let's see. Pump. What did I just do? Yeah, there you go. Press E. Okay. So yeah. So pumps are kind of components. So you want this component. Okay, so what do we want to do here? Let's say at the end of the day, I'm only interested in the final product. What the final product is that, okay, I have some inputs and outputs, right? Inputs and outputs. Let's do this here. Outputs of what? Okay, so what I'm interested in doing is having a scheme of a thing where we have a component that accepts some inputs and gives some outputs. So inlet temperature, pressure, and flow rate, and then it does some internal calculation and it'll churn out an output temperature, pressure, flow rate, that kind of a thing. Okay, so so this is what we can do. Okay, I component. Okay, we can have a component interface that's supposed to have some sort of input and output. Okay, so the input here can be temperature. Okay, inlet stream, some inlet material stream. As if you look at the pump VB over here, it will have actually an inlet stream as one of its inputs. Okay, let's stream, material stream. Yeah, ms in for material stream in, ms out as material stream out. Okay, so yeah, there is a material stream object, which is of course here it's supposed to take in this material stream object will contain all the data regarding the material stream, the enthalpy, temperature, composition, whatever is supposed to be there. And then the output is supposed to be this outlet material stream, outlet material stream object. Okay, so this is the baseline. Okay, input inlet material stream object, outlet material stream object. Okay, let me pause a while. Okay, so if you want to recenter it, just press Ctrl 0 or Ctrl 1 to zoom. Okay, and control 0. So control 1 2 times and control 0 to zoom out. Okay, so that's I think one way of doing it if you don't want to keep scrolling around. I still prefer a way where we can actually use the mouse, but whatever. Okay. Okay, the control scroll in and scroll out also seems to work, which is what I'm doing here. So that actually works. Okay, so this one will actually have inlet temperature. Okay. Okay, it's a material stream object. So okay, the whole object will be put into here. We can actually well, in each material stream object, there should be a temperature variable, pressure, flow rate. Okay. Oh, I press R and it kind of oopsie. Yeah. Okay, I don't know. I'm still using this for one of the first times. It's not the first time I'm using this. Okay, temperature, pressure, flow rate. Okay, temperature, pressure, and flow rate. Alright, let's see. Okay, so never mind. You'll just make do with the scrolling that we have. Okay, here we'll have temperature, pressure, and flow rate as well. Okay, whatever is inside the whatever's inside this material stream here. Okay, I don't know how this material stream works, so I'm just going to list it as an input and output. Okay, so all of these material stream will actually hold all the data that we need. These are material stream objects. We'll just follow the DWSim convention, so it's not to try and mess it up too much. Okay. So these are the inputs and outputs. So I component will have certain implementations. Okay. So I component is an interface that just cares about an input and output. Okay, I want to have several things you can fit into this component. So these are specific implementations, and one of them would be the pipe. Okay, I will just call this iPipe. iPipe for the pipe interface. Okay, that can be iPump. Okay, iHeater, iCooler, iHeat exchanger. Okay, so these are some of the things I would like it to do. Okay, one nice thing about the Minder, by the way, if you have too many things to focus, you can use this thing called focus mode, and that will actually make all the other things here disappear. Okay, so all of these are still in the background for sure, but at least this will give you some way to focus down, or if there's just too much information overload here. All right, so iPipe again, every interface. Okay, I will use the interface as the center of attention, so to speak. It will have inputs, outputs, and then implementations. So the implementation is what goes on behind the scenes. How are these temperature, pressure, and flow rate actually calculated? So implementations will sort of find out, how these are being done. So the pipe interface actually will be sort of the way I implement some of the I components here, right? Or rather, the pipe class, I can actually just put a concrete class here called pipe, and then that would be the implementation of the I component interface right here. That will also make sense. Okay, but I will just put a pipe interface here so that I can actually list things specific to the pipe. Okay, and then this pipe interface will have several inputs and outputs as well. However, they will be specific to the pipe. Okay, so I can put an inheritance here. It should inherit. Okay, it should inherit I component. Okay, it will inherit. What's the extra input? Okay, the extra input, I guess you might want to put pipe thickness, pipe length, pipe gradient, etc., insulation thickness, so on and so forth. Now I kind of forget I'm actually doing it for a pump, So I can actually do this as well. This is just a way for me to track how I'm actually making this diagrams. So okay, it will inherit this. Oops, Control Z please. Control Z, I don't need that, delete it. Yeah. The inputs here for the pump will be, I guess, depending on the way we actually input the pump. Alright, okay, so this is a bit tricky. Okay, there's a way you can just give it all the input data. For example, inert material stream, you can give it all the data, and then in the your output will be this outlet material stream thing. Then of course you can input like increase in head or NPSH or whatever, net positive suction head. So these are depending on the way you want to operate the pump. You can actually change your inputs. So yeah, what's the input here? What will be a good input? Okay, what will be a good input? Okay, so maybe this pump interface is just here to say, all right, let's this whole class is here to okay, let the user select the way you want to operate the pump. Do you want to operate the pump based on a certain specified outlet pressure, certain specified pressure increase, pressure drop, whatever. Okay, all of these things are kind of important. Okay, so maybe you can say pump. Maybe you can give it this variable called operation mode. Okay, operation mode. All right, so that after that, yeah, the whole idea of this pump, okay, this pump class or this pump interface is just to allow the user to select which kind of operation mode you want. Okay, so okay, the output will be well, you have to take a look at this material stream here. The output will be this outlet material stream object. Of course, for depending on how you construct this, I mean sometimes the for process simulators you can also do the backward calculation, but I'm not going to do that here. You can keep things simple for the first time round. Okay, so that depending on that, of course, the inputs and outputs will definitely change, right? So anyway, yeah, so this is the top process. Okay, so input will be some sort of operation mode, and iPump will actually be implementation. Okay, maybe you will have a pump head increase. Okay, then we can have another implementation that does, okay, pump. So this will be concrete classes, right? Concrete classes that will implement iPump. It will implement iComponent. Okay, so a class can implement more than one interface. Okay, so that's very important. Okay. Maybe I don't need to make this inherit iComponent. Okay, it's really kind of redundant here. Okay, what is this principle called? Okay, I have iPump and iComponent. Okay, and both of these will be implemented by pump head increase, pump what do you call that? Maybe pump curve, other methods of pump calculations. What is this called? This is one of the solid principles called interface segregation. Okay, in the same ways that we have one class doing one function, you should have one interface doing maybe a short set of inputs as well. Okay, you don't want one interface doing too many things, so you just keep those interfaces simple. Otherwise, yeah. Otherwise, if you try to implement a very complex interface, then there will be some of these functions here that will not be needed. So actually, just like how we try to split classes up into different sections, we also want to split interfaces up. So this is what interface segregation is about. Okay, make many small interfaces rather than one big interface that tries to do everything. Okay, so iPump will have this input called operation mode, and then the iPump implementation will be pump head increase, pump curve. What else do we have here? Okay, now if we take a look in the calculation code, okay, you have this select case me calc code. Okay, so this will actually tell you all the ways that, you know, this pump can actually be calculated. There'll be pump curve calculation mode. Okay, and what else do we have here? Keep going down. Yeah, you see all this code is just over here. Okay, then we have the energy stream calculation mode. So I'm just going to put over here pump energy stream. Okay, should all this case, the codes behind the case be here? Okay, it should not be here. Okay, all of these codes should be somewhere else, right? It should be inside maybe another class, right? Another class by its own. This whole thing should be a class on its own, because what it's supposed to do is calculate a pump function, a pump calculation based on a certain mode you specify, based on the energy stream. So don't put all this inside in this file. Put it into another file. Make it short, right? Okay, so pump energy stream. Okay, so this is called, remember we were trying to do the solid principle, single responsibility, one class, one purpose. Okay, this class here has too many things, it's trying to do too many things at one go. So I'd rather put all these calculations into another class through another interface, right? So anyway, yeah, so we have a calculation mode based on energy stream, calculation mode based on power. Okay, pump power. Okay, you base it on some certain kilowatts. I mean, both of these are pretty similar, except this one has an input of an energy stream object. Okay, delta P, which is a head increase. Maybe we'll just call it delta P just to keep it consistent. Pump delta P. What else? I'll save the Minder project first. Outlet pressure. Okay, we have to specify outlet pressure. Pump outlet pressure. Okay, so these are several of the implementations we can do so that we can tidy up this code. Again, no guarantee it will work, but at least it gives us some structure to do. Okay, so I think that's the end of this. We don't want to do too much anymore. Okay, so you can see that this whole section of code here actually takes a few hundred lines. So yeah, likely yeah, these are just different ways of calculating the same thing. What's the outlet pressure of this pump? Okay, you can base it on the delta P, all of this. So based on this, you can actually select some dependency injection based on an operation mode, and then okay, then we can actually put all of this into the component. The component itself will take in the input, which is like this material stream object here. Okay, and then based on the way you specify this in your pump interface, it can actually put this outlet, give you a correct outlet material stream. Okay, so that's how I would think this is done. Okay, you can have eye heater, eye cooler and everything, but that's for later. Okay, so what's this pump delta P supposed to take? Alright, now we can just take a look at the code here, and I guess next time we want to segregate this code out. Okay, but yeah, this whole thing right here is just to show you, hey, maybe it's a good idea. Yeah, maybe it's a good idea to use Minder as a tool to try and map out how we want a function to work. All right, how we want a function to work or library to be connected. So that yeah, let's say we are doing this pump delta P, we know where it's supposed to be. So start designing. If we want to do code refactoring, which is to tidy up code, or we want to write new code, always have this mind map here of inputs and outputs that, as far as possible, adhere to this solid principles, okay, before you even start writing your first code. Okay, so this is the code writing before everything else, so that at least you know what's going on, and make sure you are able to trace the inputs and outputs from start to finish of these various classes. Okay, so just make it in a way that it's legible for yourself, and hopefully for other coders as well. Maybe put some comments here and there. Okay, but that's all. I hope it's a good tool. I find it useful to try and sort out the mess of things. Okay, mess of things that I'm trying to do with this DWSim components. Alright, so I think that's all for this video. I don't know if it's helpful to you, but I think it's a good way forward to try and make sense of a very complicated inheritance and everything. Alright, just gives you some idea, and you can see everything in one page. Okay, so that's enough for today. I'll see you.